All right, guys. In this video, second part of chapter 2, we'll be talking about the evolution of quality. As you know, the quality did not just it comes and happen immediately. It goes through a process, steps and phases. Moved from the basic one into a more advanced one, as any other sciences in this life. So if you look into this chart right here, what you will see the it started with the quality of a handmade products or services. As you see the old days where people there was no technology, there's no advanced tools. The people used to do the product using their hands, and they're sure, as you see if you look into the history for the cities and the old version of the cars and the old models of these products, you will see how high quality is these products, how reliable is these products. And now what you see in this evolution of quality, you will see that after the hands made products and the quality for the hands-made products, we've seen a lot of improvements in moving that into inspections, and then from inspections to quality control, then statistical quality control, and then statistical process control, and then that would move us into the total quality management, then continuous improvement, Six Sigma, and then could be something else in the future. Just to go over some of these basics here on what's the evolution for quality, we'll find inspections. What is inspection? So we need to go over each one of these concepts and hopefully we'll explain it. Inspection refers to these activities that are designed to detect and find non-conformance. We need to find any activity that will help you to find defects that could be called inspection. Uh, uh, and for inspection could involve some measuring, examining, testing, gauging, and any other tools that we could do to figure out the characteristic, whether any if there's any defects in the characteristic of the products or services. Again, inspections is the activities that are designed to detect defects, non-conformances existing in already completed product, something that we have a completed product, we have a completed product. Now what we need to do in order to inspect this product, we need to measure it, examine it, and look around and see if that's meet the standards or not. I did provided a video here for you. You could maybe could look at different ways to do inspections, such as gauging, as I mentioned here, examining, testing, and measuring, and other tools as well. The next evolve that I want to focus on is the quality control. So what's the difference between inspection and quality control? Inspection is as I mentioned, is the value that you use to find the defects in a complete product. Quality control refers to the use for specifications and inspections of completed parts and products to design product review, sustain, and improve the quality of product or services. So now uh, the use of specification is basically the quality control. How to control the quality is you use these specification to do the inspection. So the inspection is the act of measuring, gauging. The quality control is the specification. It's giving you the direction and the guidelines on how to do the inspections. So again, it is the use of a specification and inspection of complete parts or services to design product, review, sustain, and improve the quality of product or services. Statistical quality control. That's involved collecting some statistical data. Statistical quality control is involved with statistical data, collecting some data, analyzing it, and interpreting it to solve problems. Statistical process control. Now we're going in moving into another phase, which is the statistical process control, which basically prevents defects by applying statistical methods to control process making product or providing services. Statistical process control, again, prevents defects. How it does it prevent defects? By applying statistical methods. So what's the difference between the statistical quality control? The first one is collecting statistical data, analyze it, interpreting to solve the issue, the problem. The second one is applying statistical method to control the process making products or providing services. The next phase is the total quality management, which is the management approach. It is the more broader approach that will emphasize on continuous improvement for whether the process itself at small scales or the system as all, as a means of achieving customer satisfaction to ensure long-term company success, to ensure the long-term company success. This is the whole goal for the total quality management, is applying these continuous improvement for the system or for a specific detailed processes to achieve the long term. The long term is the most important. Continuous improvement, just to focus on continuous improvement, is focusing on improving the process in order to enable companies to give customer what they want the first time, every time. So continuous improvement, what you can do to provide a better service, a better product, look for improvements. You have to keep moving with your goal, with your quality. You don't want to stop at one place and say, I'm done. You need to continue improving your process in order to achieve a better customer satisfactions. There is so many achievements also in these advanced years. We've seen quality standards such as the ISO 9000, which is basically created to deal with globalization. We've seen a lot of globalization. We need to deal with companies from all over the places, all over the world, and we need to ensure there is a quality for these standards, for these products and services. So this ISO 9000 created to enable and facilitate the globalization and dealing with each other. To facilitate doing businesses in a variety of countries, a series of quality standards was developed by the International Organization for Standardization. What is the key principles? There are 8 key principles are integrated in the ISO 9000. These are customer focused. We need to keep in mind that we need to focus on customer. The customer is number one, the goal number one. We need to satisfy that customer. Number 2 is leadership involvement. We need leadership be interested in improving the quality. If there's no interest from leadership, there's nothing going to happen. There's no quality will be improved. Number 3, involvement of people. We need also the people who is working on the front line to be part of the quality improvement. We need them to achieve these improvement, and we need to get their feedback and input on how we could improve the process. Next one is process approach. We need to look into the process approach, the details, all the details, as well as the system approach, the bigger details, the bigger picture of quality. Continuous improvement. Keep in mind that there's nothing called you reach the goal. The goal is a moving target. You have to continue improving your process, your service, your product. Factual approach to decision making. You need to use data, not based on your decisions or opinions or thoughts. It is all based on data. What the data tells you, you have to use this to improve that quality. And mutual beneficial supplier relationship. In the old days, we used to deal with the supplier as a separate entity, as an enemy. People used to call it enemy of us. They want to squeeze the supplier to get the best price from them. Now, these days, with the ISO 9000, we don't have this vision for the suppliers. We deal with the suppliers as partners, and we need to help them to succeed as well. They will help us to succeed as well. So there's a mutual beneficial between us and the suppliers. More advanced methodology for quality, such as lean, and lean is about reducing waste and improving the process. It's increased the system reliability and reduce failure rates. And Part of this lean, it's some tools called Lean Six Sigma. Some people they consider it as a separate, but anything will help you to remove waste will be under lean, and this is my own opinion. And I think Six Sigma will improve the process and remove the waste from the process. Therefore, Six Sigma is under lean. Six Sigma seeks to improve quality through reduce of variation for every product with an ultimate goal virtually eliminating all defects. In fact, we are reaching to a goal to the goal for applying Six Sigma is to reach to 3.4 defects per million parts. Lean production focuses on driving waste out of the process of production cycle. We need to do more with the fewer resources, which means we need to look into improving productivity. We look into optimization for resources. Some of the tools that we use in Lean, the MAC cycle, which is the Six Sigma, Kaizen, which is continuous improvement, quality circles, in meet with all the members from all the company, all the departments has to have an input and talk to them from their perspective what we should do to improve the quality. Visual management, you will put some signage and make it clear for people how to do their job. 5S, do the standardization, cleaning, and other 5S aspects that will help you to remove the waste and reach to a standardization. Standardized work procedures. These are step by step. Step number one, do this. Number two, do this. Number three, do this, etc. This will help bring productivity to a more to a higher level and will make it clear for people how to do their job with less defects. Preventive maintenance efforts, and we have to maintain the machines, the setting up and adjusting these machines. Preventive maintenance is a great tool to remove waste and keep my team productive. Uh, some of the advantage why we need quality. We need the quality to meet customer expectation. Just to summarize why quality is important, we need to meet customer expectation, and we need to reach to the product specification. Reduce variation, we need to remove all the waste, we need to remove the variation from the process, keep it as a standard process. Achieve process stability, we need the process to be stable, and this is you could do it through the quality. Minimize production cost by eliminating cost associated with scrapping or reworking out of specification. We don't want to redo the work again and again. Just do it right from the first time, and support decisions with the statistical and data. We need to provide some rational why we made these decisions. We need to support our decisions with data and information, and this will help hopefully increase profits and sustain the place in the marketplace, and also achieve excellent in service and production. With that said, I would like to thank you. That's the end of chapter 1, and we'll see you in another chapter 2. See ya.